So again, that bond is so weak when I look at something like this that I can cancel the 4's and x over y. Okay, I'm done. That's good. Okay. Now, it may not be quite as obvious every time. Sometimes I may have to actually use some rules that I've had in other places. For instance, okay, 3 and 5, okay, none of that. That doesn't break down at all. I just got to leave that alone. But I have exponent rules to play with on the x's. So what do I do with exponents when I'm dividing? We subtract them. And we go bigger minus smaller, so 2 minus 1 is 1. And wherever the bigger exponent is, that's where my answer goes. So if the 2 would have been on the bottom in the denominator, that's where I'd have put my x value. But here comes the stuff that's a little bit different. So now, let's say stuff's factored out, or after we've factored it out. Okay? For us to cancel these, you need to have identical sets of parentheses to cancel. Okay? Those things are bonded. The bond is, strong. How do I know that? Because I can see the bond, whether it's plus or minus. And the parentheses are there to tell me that even once more. So for instance, I can cancel those x plus 3's. They're identical. I can cancel the x plus 4's. They're identical. Here's what I can't do. Let me rewrite what we have left. And again, this is why I'm a proponent of keeping parentheses around. You cannot cancel those x's out. Okay? Bonded. Strong relationship. I always usually go to a goofy comparison, so I'm going to go there again with this. It's sort of like, yeah, why not? I'll go there. It's sort of like high school dating. Over here, okay, we're kind of walking down the hall. We're doing our thing, but nobody really knows we're doing anything because you really can't tell by the outside look. It's real easy to break this up. Over here, much harder. This is like exchange class rings and all sorts of stuff like that. The bond is strong. Okay, I'm showing my age. Oh, well. But you get my point. I see the bond is stronger here, and the only way I'm breaking the bond is by identical things coming along. So when I get to 4, question.
Wait, that's it? We're done with that one?
This one is done.
Wow.
Okay, here's the catch, though. 4. Can I cancel the x squareds?
There's a thing you do to cancel that.
No, I can't.
Wait, you can't divide?
There is a bond there. Plus or minus binds those two terms together, the x squared and the 5x. It's a package deal now. But here's the question. Do those two terms have anything in common?
X.
Okay. So I can take an x out. X times what gets me to x squared? X plus 5. Okay, now let's take a look again at this. Because the situation has changed slightly. This part that's on the outside that's not bonded, that's fair game to reduce now. So now I can go back to sort of like what we did on number 2. I have exponent rules that I can use now for that piece of this. So I look and I go, okay, yep, 2 minus 1 is 1, but the bigger exponent's down in the denominator. The x plus 5 is still up here, but again, it's bonded. Don't cancel the x's. I'm done. Sorry. Yeah, don't do it. That's going to be the biggest thing through all of these. So I'm gonna really hound on this. Whenever you see a plus or minus, okay, within a problem, you need to immediately, if they're not on there already, put parentheses around them. So you're not that person that cancels out the x squareds and then minus 4's because you think, oh, that's fine, I can just come in and do this. No, you can't. Okay, there will be no home wreckers on this stuff. So, but it doesn't mean that situations can't change if they're factorable. So if I look at up in the numerator, I think I can factor that using a diamond. I'm going to find out. So I need two numbers that multiply to negative 12 and add to negative 4. Well, I know it's one positive and one negative because it's a negative product, and I know the bigger number is going to be negative. So two numbers that multiply to 12 that are 4 apart. 6 and 2. Okay, so we've got that factored. Then what about down in the denominator? Do not leave it alone. Perfect squares. It's a difference of squares. What do I square to get x squared? X. What do I square to get 4? 2. And it's plus and minus. So now we take a second look back at what's going on here. Do I have any identical sets of parentheses? I do. So I can whack those, and what's left is what the answer is. But again, only identical gets to get whacked out of there. So just keep telling yourself. I see a plus or minus. Those are bonded. So as far as our bonded group here in the bottom goes, anything in common? 5. Anything else? X. And then again, whatever's left over. You can always do this divided by this if you want to, or you can just say 5 times what's 10? Okay, it's 2. And I need an x. Plus 3, right, because I already got the 1x. I don't need another one. And just like we had up in number 4 now, the part that's not in the parentheses is fair game to cancel or reduce. Okay, the 5's are identical. Whack. And use my exponent rules to finish it. So I got my fraction here. 2 minus 1 is 1. Bigger exponents up top. We're good. Leave my 2x plus 3 alone. It's bonded. Don't cancel. We're good. Now, at this point, some of you may be sitting there going, okay, so anytime I got to factor because something is always going to cancel out. Not always. For instance, I look at number 7. I'm like, okay, parentheses, parentheses. Okay. Can I factor the numerator? It is a difference of squares. Nicely done. So x, and then 9 would be 3 and 3. Okay. Can I factor the denominator at all? No, they don't have anything in common. I can't even pull like a 2 out or anything. You're like, Harty, there's nothing to cancel. That's right. Does it mean that I shouldn't factor every time? No. Because what if there was something small that you didn't see and then you factor and you're like, ooh, now I can cancel this. So you do need to factor, even if you're thinking nothing's going to cancel, because about the time you don't, it's going to be the time it cancels. And it's going to be bad for you. Okay. 8. Cancel the x squareds? Yes, that was my head hitting the desk. Okay. No, because again, that's all bonded right now. Unless those were absolutely identical all the way across, I can't do anything yet. I think I'm going to be able to, though. All right. Notice how you're going to get lots of practice on your mental math and diamonds with these. 6 and 4. And again, they're both negative because I'm multiplying to a positive, but I'm adding to a negative, which tells me they've got to be the same sign. Then I get down here and I notice it's a negative product, which tells me it's positive and negative. So 4 apart, multiplying to 12, 2 and 6. Bigger number's negative, because again, I need a negative sum. Now if I see things that are identical, now I can blast them. But that's the only time I can. Okay? So if you just have a singular fraction, you do. You factor it as much as you can. You cancel out what's cancelable legally. And then you're done. Okay. This might not be terrible. Maybe. So then we bump it up a little. So I get down here to multiplying monomials. Now this is just my opinion. There are some people that can start canceling right away, because notice there's no plus or minus here. I can start canceling right away if I want to, but it tends to get messy and people tend then to start making mistakes. So my suggestion when it's monomials, no pluses and minuses, is to multiply straight across so we can get down to one fraction. So I'm still going to multiply my coefficients, multiply the big numbers in front, but then when we're multiplying with variable terms, we add the exponents. So 2 plus 3 gives me x to the 5th. And then again, there's still a 1 on that y, even though I don't see it. 1 plus 2 is 3. And I'm going to do the same thing in the denominator. 2 times 10, they're not exponents, so they don't play by the exponents rules. I just got the single x term. And then y, I've got 3 plus 1, which is 4. So I get there, and I'm like, okay. Now it's just a big reducing game. So again, whether you go to your calculator and do 30 divided by 20, math, enter, we don't do decimals on these. Okay, that's going to end up at 3 over 2, because they're both divisible by 10. And then I just use my division exponent rules. 5 minus 1's 4. Bigger one's up top. That's where my answer goes. 4 minus 3 is 1. Bigger one's in the denominator. That's where my answer goes. So for any of these, as you're doing them, we're not going to do all of these because I don't want to go into overkill, especially since some of you already noticed this is a packet. And I do want to do one more here. So let's say we do 12. Actually, yeah, that's good. So if I multiply straight across, 15 times 12 is 180. Add my exponents on my x's. Y, I only have a single one. Okay, denominator, 4 times 5 is 20. Add my exponents on my x's. Y, there's only one. And I start to look at this and I go, okay, 180 divided by 20 is 9. And again, 180 is bigger, so I'm putting the number. It started as a fraction. I'm leaving it as a fraction for right now. 4 minus 2 is 2. Goes up top. And if your variable terms have the same exponent, they go away. So really my answer is just 9x squared. If you want to leave it as a fraction, put it over 1, you can, but you don't need to, since everything's up in the numerator anyway. Okay? So again, monomials, suggestion, multiply straight across, then reduce things, because it's just going to make your life easier. Then we step up a little more. What's all this? Well, I notice one thing right away. I see pluses and minuses, so we're going to get ourselves out of thinking we can just cancel right away here. Okay, here we go. We're going to go term by term, seeing what we can factor and what we can't. So the rest of this stuff does not exist right now. That is the only thing that exists. What do those two things have in common? So I can get a 4 out of there. I can get an x out of there. Okay, everything I can get out of there, I need to get out. And then you're like, well, wait a minute, though. If I took out 4x, and this is 4x, I don't have anything to multiply it by. Use a 1 as a placeholder. Don't try to do anything fancy and act like it doesn't exist. 4 times what to get to -4, -1. I already have an x. I need to get to 2 of them. I need 1 more x there. Okay, we're going to take it in pieces. Once I've factored that first one, I move to the next part. I go, okay, multiplying. Two numbers to get a -3, so I know it's one of each. So let's see here. Multiply to 3, the numbers are 2 apart. I really don't have many options because 3 and 1 are the only two numbers that multiply there. So, 3 and 1. And I move from there. I get to the next one, and again, we got factoring involved. Again, I'm multiplying to a negative, so I know I get one of each. Multiply to 6, 1 apart. 3 and 2. And again, the 3 is the positive because I need my sum to be positive. And then I finally get to something that I don't have to do anything. So I can just write down the 4x. So, okay. Here now becomes the question. Anything that I see that is identical, I can cancel at this point. So, the 4x's, I cancel. The x plus 3's, I cancel. Then I have to stop and think for a minute. Because I'm staring at these and I'm going, is 1 minus x and x minus 1 the same thing?
Yes.
Close, but no.
What?
Well, let's think about this for a second. Okay, 1 minus x and x minus 1. Let's plug in a number for x, like 5.
Oh, no, that's not.
Is 1 minus 5 and 5 minus 1 the same thing? No. But can I manipulate this so they are? Yes. Like, really? Yeah. How do you do that? Okay. Watch this little slick trick. If I pull a -1 out front, okay, I'm going to pull this negative out here. That changes the signs on both of these. So now the question becomes, is -1 plus x the same thing as x minus 1? The x's are both positive. The 1's are both negative. They're the same thing now. So by pulling that negative out, ooh, you're like, now wait a minute, how's that work then? The negative can still be here. It can be like having a -1. So now if I look up top, I'm like, okay, I got the negative. Canceled, canceled, canceled. I still got this. And down below, everything's gone. So by putting the negative out front, and somebody may say, should I distribute it through? Should I write -x plus 2? You could. You don't have to, but you can. And that's what this becomes. It all becomes about multiplying and dividing and canceling stuff and kind of taking your time with this. Okay. Let's patience. Patience, patience. The whole world is hearing what you say. So, and I just kind of work my way through. Now, I got lucky this time because I just saw that one over here, so I know what it's going to look like. But again, piece by piece, fraction by fraction. Don't try to take it all at once. I was bad. I didn't put my parentheses in at the start, so I don't do anything silly. And again, it doesn't have to be something huge that you take out. It can be something as small as just a number, like here. I can take a 2 out of those. Because 2 times x is 2x, and 2 times 4 is 8. And then I go diamond on that last one. 4 and 3. Now that I've done all my factoring, now I can start trying to whack away at things.
X plus 3.
X plus 3's cancel.
X plus 4.
X plus 4's cancel. Can I whack the 2's? Yes. Okay. They're not in parentheses. There's no plus or minus sitting there. I can whack.
So the x minus 2 over x squared.
X minus 2 over x squared. Keep those parentheses because don't do all that good work and then try to cancel the x's and have me go crazy. Okay, one more in this section. We're going to throw a weird one out at you. Should do 16? I was going to say 15 and 16 are the exact same thing, actually. Way large. Okay, let's do 16. Okay, parentheses, parentheses. I already got parentheses there. Okay. So, x plus 2, I can't do anything. Okay. The second part. Now, let's look at this for a minute. There are two terms there. All right. Two terms. Look at the numbers, 8 and 27.
Oh, they're perfect cubes.
Perfect cubes. Okay. This is a sum of cubes. So I look to see what I multiply, or what I cube to get each part. I cubed 3x to get 27x cubed. I cubed 2 to get 8, because 2 to the third power is 8, 3 to the third power is 27. So then I go and I follow my pattern to factor that. So again, this is why we keep our sheet handy. We go, okay, 3x, there's a plus in the middle, so 3x plus 2. And then follow the pattern. Square the first term. That's the 3 and the x. 9x squared. Change the sign in the middle. Multiply them together. And then I'm going to square my last term. That's factored. Now, before you go trying to do slide and divide or something slick on the second part, let's think about this for a minute. Look at what it is and look at what you just factored. I can cancel them out. Boom. Boom. So see, this one looks awful, but it's actually one of the easier ones because that's going to happen. You're going to factor that, it's going to be like whack, smack that whole big thing out of there. And no worries. Now, I've got one little piece left that I want to hit upon. Let's see here. I'm not going to worry about part 6. We'll play with part 6 on Tuesday. Okay. So if I just play with these last couple on this page, we'll be okay. So let me move this up a bit. Sure. All right. Same rules apply, except remember, when we're dividing, we need to flip the second fraction, because if you do that, dividing is same as multiplying by the reciprocal. So when I'm doing these, after I put my parentheses in, of course, if you need to actually rewrite this, and I'm going to on this first one, so I don't forget, I leave the first fraction alone, and when I flip the second fraction, it goes from division to multiplication, because we're multiplying by the reciprocal. So now it turns into just like what we've been doing in part 3. So if you get to a point that you can remember that and not have to rewrite it and flip it, that's fine. But otherwise, again, piece by piece, always look first to see if there's anything in common, and there is this time. 3 times what gets me to 3x? 3 times what gets me to negative 12? And I just continue to keep working it piece by piece. Okay, that's going to be a diamond problem. We're going to get lots of those in here. You're going to be middle math experts by the time you're done with this section, if you're not already. Multiply to a positive, which means they're both positive or both negative. Oh, they're both negative. Okay. 4 and 2. And then finally, anything in common? Yes, they both have an x. X times what is x squared? X. X times what is negative 2x? Negative 2. And now it becomes a canceling fest. We can cancel, we can cross cancel, we can cancel numerator to denominator. The only way we can't cancel is like horizontally, side to side. So cross cancel is good, numerator denominator is good. Lonely x's are good. They're not bonded, that's fair game. So what have I got left here? I got 5, and I got 3. You're like, really? It all went down to 5, 30? Yeah. That's all it takes sometimes. That's all it takes. But again, that's what we're playing with these. Okay, last one. Piece by piece, people. Piece by piece. I can get a 5, and I can get an x. So what's that leave me with? Well, I got the 5 already. X to x squared, I need an x. 5 to 10, I need a 2. Yeah, I'm gonna get to, when I get to that second fraction, I am. I'm gonna show it both ways, and people can kind of determine which way they want to go. So let's see, multiply to a negative, so I know it's one of each. Multiply to 6, one apart, that's 3 and 2. The 3 is going to be my negative. And again, when I go to do this, because I also have people that do this, they might draw arrows to remind themselves, like, I got to flip it. So this is what I'm actually factoring here right now. So I've got a difference of squares, x and x. 3 times 3 is 9. And again, to get the negative 9, I got to have one of each sign. And then finally, this is my denominator. So I get working, and I'm like, okay, I can take a 15 out of both of those. And sometimes you may take something out that's too small. Maybe you take a 5 out instead. And then you're like, well, nothing's canceling out. Oh, I could take more. And then you go back and figure it out. Here, again, the smaller exponent that you see is what you take out. So the x squared. So I already got the 15. X squared to x to the third, I need one more x. 15 times what is 45? That would be 3. And I already have the x squared, so no more x's there. Again, once I'm fully factored out, canceling fest. Woo! X plus 2's, x minus 3's, x plus 3's. Now maybe at this point you're like, okay, what have I got left to deal with here? I got the 5x. Okay, so you can reduce your fraction. 5 over 15 is 1/3, so you could just put the 3 on the bottom, or if you want to put 1/3, you can. And then again, exponent rules. 2 minus 1 is 1. Bigger exponents on the bottom. Now, your job is on the front of this. And this is some of yours Achilles heel right now. I'm not quite sure why that is, but it is. So I'll make the same suggestion that I tend to make a lot of the time with these. As a book assignment, it does not mean you physically need the book. It just means grab the book, take a picture of one page. One page, that's it. Take it with. It's okay. All right, and then we'll deal with some more of these when I see you again, worksheet style.